Hi students, in this video we're going to look at applying synthetic division. Now, synthetic division is an alternative method of carrying out polynomial division. So what we're going to do in this video is learn how to apply synthetic division to divide polynomials by a factor. Alright, just like with polynomial division, synthetic division relies on long division and that process, that algorithm, to help us get to our solution. So if you remember how to do that, that will be helpful for this video as well. Now, synthetic division is just an alternative method to polynomial division. It applies the same sort of process as polynomial division, but without a lot of x's and without a lot of the confusing parts of polynomial division, basically getting rid of all the x terms and the variables and just dealing with the coefficients. So there's a bit more to remember with how to apply the process, but once you do, you might like it as an alternative to polynomial division. All right, so we've got the same problem as before. We've got our polynomial, dividing it by x minus 2, and then writing our polynomial in the form x minus 2 times our quotient plus our remainder. Now, from here, how we apply synthetic division is, first of all, we write out the coefficients of our polynomial function here. So we've got 3, -2, 5, -3. And those are the coefficients of our x cubed term, x squared term, x term, and our constant at the end. Now we're going to apply a process here that looks a bit like our division sign, just put it around the other way. And we're going to use our -2 value here. Now the first step for synthetic division is we drop the first number down to the bottom. So that 3 becomes a 3 at the very bottom here. And then from here, just like with long division, we're going to times 3 by -2 and put that value up here. So 3 times -2 gives us -6. And then just like with long division, we're going to subtract those two values. -2 subtract -6 gives us 4. And then we keep applying that same process. So 4 times -2 gives us -8. Let's get the right color happening. 5 subtract -8 gives us 13. What I might do is I'll include a line here. And then up to the next term, -2 times 13 gives us -26. -3 subtract -26 gives us 23. Now these numbers at the bottom give us the coefficients of our quotient, Q function. It also gives us our remainder. So looking here, right at the very front here, this is now the coefficient of our x squared term. So notice that our powers in this column have gone down by 1. So our x cubed coefficient was 3. In our quotient, our x squared coefficient is 3. And then in the same way, it keeps going. And that's our x coefficient. This is our constant. And then this term at the end, so I put that little line in to keep it separate, that part at the end is our remainder. So we can now write out our function where this part here is our quotient function. And so writing out our polynomial is our divisor, which was x minus 2. Our quotient function, now we've got our coefficients and our terms here, so it's 3x squared plus 4x plus our constant, which is 13, and then our remainder at the end was 23. And there's our function. after applying some polynomial division. Now, so synthetic division, it does the same thing as polynomial division, but notice how there's far less x terms around, and it's just an algorithm, a process to follow, going from one term to the next. Key mistakes that are made are forgetting that in our answer, in our quotient, the powers go down by 1. So x cubed needs to become x squared needs to become x needs to become our constant, and our constant needs to become our remainder. This also cannot be used if our linear factor is, if our x term has a number in front. So for example, if our divisor is 3x minus 1, synthetic division will not work as well. You should just apply polynomial division. So it only works well if our linear divisor, if our x value has a coefficient of 1. That's the only time synthetic division will work. So it's often useful to have both synthetic and polynomial together. If you prefer synthetic, you can use that most of the time. But as soon as you have that coefficient of x that isn't 1 anymore, usually applying polynomial division will get an answer a bit more easily than applying synthetic division. Right, so after watching this video, you should be able to apply synthetic division to divide polynomials by a linear factor.